Questions on the homework? Any of those you'd like to see done? Clarify. Yes.
Could we do like either like 15 or 17? I kind of understood how we got the equations, but the actual graphic is confusing.
Do you know what they are? Or do you want me to grab my book?
Could you grab them? Sorry.
I don't know if I can or not. Do we know what 15 or 17 is?
Which homework? 2? Oh yeah, homework 2, sorry. I have written here r equals 1 minus sine of theta. I believe what we had to do was graph it. Put that in polar in the graphic. I mean, not polar.
2, this is 15, is that right?
Yes. No, that's 17, sorry.
17. All we're doing is graphing it?
Yeah.
Okay, so this is what we call, when it's in the form a plus b sine theta or a plus b cosine theta. That's known as a limosome. So this is some French word that has that funky looking C there where part of it goes that way and part of it turns around and goes the other way. What's that?
Kind of looks like an S.
Kind of looks like an S, but yeah, I think the little bottom part's not quite as big as the top part. I don't know, it's a French thing. So it's pronounced like an S, so it's a limosome. So at any rate, we don't really have to know that. All we're going to do to graph all limasomes is we're going to plug in, they're called the quadrantal angles. That is the angles that give you the boundaries of the quadrant. And then we're going to just find what the R is. And then if we think like Doppler radar, then we can sweep through and connect those and get what it's supposed to look like. So at theta equals 0, sine of 0 is 0, so R is 1. And so we get just 1. And we label these, now on this one, polar and rectangular are the same, but this is the only place that that's going to be the case. So we label them in general with rectangular coordinates. So we find the points using polars, but we label them as rectangulars. So when we put in pi over 2, sine pi over 2 is 1, 1 minus 1 is 0, R is 0, so going up this way, we don't go anywhere. It's at the pole or the origin. When you plug in pi, sine of pi is 0, so we're back to 1 again. So going on the angle pi, we come out 1, and that's going to put us at negative 1, 0. I guess we can label that as 0, 0. You with me, or am I going too fast?
No, I'm with you.
Okay, and then put in 3 pi over 2. At 3 pi over 2, sine is negative 1. 1 minus negative 1 makes r 2. So on the angle 3 pi over 2, we come out from the pole 2. That's going to be called 0, negative 2, because that's what it would be in rectangulars. Is that okay? Now to graph these, it's kind of weird, but you imagine, you're standing there like Doppler radar, and you're going to sweep through here. And as you sweep through here, the R values are going from 1 to 0. So they're going to get smaller, and it's going to look something like that. And then as you go from pi over 2 to pi, it goes from 0 to 1. Remember, that was an R value of 1. So you're going to get the mirror image of that in this case. And then going from pi to 3 pi over 2, as we sweep here, the R's are getting bigger, going from 1 to 2. So we'll smoothly connect here. And then we'll go back here from 2 to 1, and we will smoothly connect that, and it is, it's a heart. So we call that actually cardioid. Cardioid. True. Okay.
Could you do 31?
31. Is this okay on that?
Yes.
Can I just throw it? 31.
Graph r equals e to the theta.
E to the theta. Oh, goodness gracious. E to the theta. Whew, I think this might be one for our graphing calculator, to be honest with you. I don't think it's cheating here. You will have to be, you supposedly have to know, and you will for my test. I'm not sure they even ask you to do this anymore on the AP exam. But in theory, you need to be able to graph limasomes that we talked about, rose curves, and lemniscates. But this is going to be pretty wild and crazy. So I would honestly, and you may have to play with the window, and you might let theta, because theta is going to be, like you're going to put in, it'll be theta that will appear on the graphing calculator. But you got to choose your window big enough to make it really look cool. Because this is going to be really big. We can kind of see what's going to happen, because at 0, when theta is 0, you're going to e to the 0 is 1. So you're going to start at 1. But as you sweep along here, an exponential is going to get really big really fast. So it's going to, I think it's going to be like a spiral out of control that's going to get really, really big as you get around there. So you're going to have to kind of play with the window because otherwise it's going to disappear off the screen. And so you may have to change, the X min, X max, Y min, Y max. To make it look the way it's supposed to too, because your screen is rectangular, you want to make it's called the aspect ratio. You want the X values, the X min and X max to be 1.5 times the Y's. If you make them be the same, the circle is going to look squished. It's going to look like an ellipse. So it will look more appealing to your eye if you choose the X min and X max to be 1.5 times the Y min and Y max. Gotcha.
So going back to 17, I really struggled with finding the rectangular equation on that one.
70, oh, those are tough. Yeah, okay. So back to 17. And do you know what that one is?
It was r equals 1 minus sine theta.
1 minus sine theta. And we're supposed to find rectangulars here?
Mm-hmm.
Yeah, along with graphing.
Along with graphing it.
I was okay on that.
Yeah, me too.
I'm not sure you can find I think you can find an implicit function, but not
Yeah, and I think even that's going to be a mess, right? So what comes to my mind, I think this is going to be really messy. But one you can see, it was a cardioid, and we've never seen that before in all of our history going back in rectangulars, because it isn't going to work nice. I think what I would try is multiplying by r, but it's still going to be really, really messy. So this will be r squared, that will be r, and this will be a minus r sine theta. And I mean, this may get us to about as good as we're going to get. Now, we know that r is the square root of x squared plus y squared. So r squared isn't nice, it just removes that radical. Is that okay? So this part is going to be an x squared plus y squared. And the bad news is that r is stuck there, and there's not a great way to do anything with that. So I think we're stuck needing that. Now r sine theta we hopefully recognize as a y. And I would probably wipe my hands of that and walk away as quick as we can, because anything else we do is just going to get bigger and messier and worse. Theoretically you can get the radical by itself, bring that over there, and then square both sides, but I'm not really wanting to square trinomial there.
So I skipped it.
Yeah. In this case, I think that was a good idea. Anything else?
Can I do homework 3?
Or 3? And anyone in particular?
23?
Problem number 3?
23.
23. You know what that is, Greg?
I don't know what we're supposed to do.
Does anyone know what it is?
I have it on my phone.
Nice.
Oh, you had to there was something about A and B.
Visual thinking, suppose that A plus BI is multiplied by 1 plus I. By how many degrees must the arrow from 0, 0 to AB be rotated to coincide with the arrow from 0, 0 to the product?
Oh, I remember this one.
I wasn't even sure.
Yeah, that was
Okay. So here, that's a great thought. So this is tricky. So the idea is we're going to take this, and remember, think now that this has a polar representation, right? And remember, you guys weren't here for this, but we called it r cis theta, crazily enough. So this is going to be r cis theta. I don't know what the r is, I don't know what the theta is. But we can tell what the r and the theta is of 1 plus I. You with me? So let's convert this into polar form. So the r is going to be the square root of 1 squared plus 1 squared. Any nods of heads? You with me there?
Yes.
Okay?
Yes.
Okay. Did you fall asleep in this part? So this is all new and different?
I got it.
Okay. Now I would just, you can do the inverse tangent and all that, but I would just kind of think of it, because I think if you just graph it for a minute. Remember, this is our Argon diagram. So the horizontal is the real axis, and the vertical is the imaginary axis. So 1 plus 1i means you're going to go over 1, up 1. There is your point, 1 plus 1i. Now, if you connect that, then I think you can, at a glance, tell what that angle theta is. Pi over 4, 45 degrees. Is that okay? So, any preference, radians, degrees? Radians. So we'll call pi over 4. So that means we have our r and our theta. So when we multiply this unknown complex number by the one where we do know that it's going to be square root of 2 cis pi over 4. And you remember the way we multiply these in polar form is really slick, right? You multiply them, you just multiply their r values. So that's going to be r times the square root of 2. And you add their angles. So you're going to get whatever that theta was for the first one, I don't know. But we're going to add the pi over 4 to that. So now imagine you're going to turn around and graph this thing. So when you go to graph this thing, you're going to go to whatever theta was, and then what more angle are you going to go? So you're adding that pi over 4, 90 degrees to that, and then you're going to go out the square root of 2 plus whatever r was. So they're asking you that original a plus bi, think now r cis theta, when you multiply it by 1 plus I, it's going to rotate that or move it, whatever the angle was for 1 plus I, which in this case is pi over 4 or 90 degrees. And then it will, if you want to go another step, what's it going to multiply the length by? It's going to multiply it by the square root of 2, the r value of the 1 plus I. Kind of fascinating the way complex numbers work. I mean, talking about polars just puts them in a whole new light. You know, you see them in a very different way. And you're going to see that with what we talk about today too. It's like, oh my gosh, it's pretty powerful. Other questions? Okay, wow, let's blaze on here. I have to find where I put my brains. I laid them down over here. So we're going to try to talk about powers and roots today of complex numbers. Powers, I don't think is going to be too earth-shattering. Roots, on the other hand, you may feel the ground move. So this is going to be 11.3 powers of complex numbers. So what we learned last time is that if you take a number, say x, and whatever that complex number may be, I'm going to say a plus bi, well, we're going to convert it to our polar representation, r cis theta, because that's where we want to do arithmetic, or at least if we're going to do multiplication, division, powers, or roots. Adding and subtracting is going to be easier when it's in rectangular form, because you just add their real parts and add their imaginaries. But once you start doing other stuff, you want to go here.
When you say rectangular form, you just mean a plus bi.
Yes, yes.
Okay.
Yeah, and so, yeah, that's a great point. Rectangular form refers to a plus bi. And then, oh, we have a visitor.
Fire inspection.
Oh, fire inspection. Uh-oh. This can't be good.
That's right, you've got 2 pencils, you have 20 seconds to start a fire. There's nothing.
Oh, that's gonna, I'm okay?
I am an expert on the fishing line puzzle.
Well, that was the one that was worrying me.
You are awesome, thank you.
Thank you. I was going to have to reconfigure everything there. How many things can you have out of one outlet? So here we know that when we multiply two numbers in polar form, you multiply their r's and you add their angles. So if we take x times x, which is how we're going to think of x squared, then what would that look like?
R squared.
Yeah, I was hoping that there were a lot of people who were going to say that. That's exactly right. Right? Because the r values are going to multiply each other, but they're the same r value. You with me? I need nods of heads here. Well, we just got, okay. And then you're going to add their angles, but it's the same angle, so it's going to make 2 theta. Oh. So if we take x to the third, which is x squared times x, what is that going to look like? Oh, get the hang of it. R cubed cis 3 theta. Is that crazy? So the big leap, x to the n, any power we want, is going to be cis and theta. Amazing. Just wait, it gets better. So this is actually known as de Moivre's theorem, another terrific French mathematician. So if I can spell it right, but who knows, it's French, right? De Moivre, V-R-E-S, de Moivre's theorem. Okay, so let's do an example. We'll take a number that's in rectangular form, 1 plus I squared to 3. So let's find 1 plus I squared to 3 to the third power. Now, you actually probably had to do a problem like this. I don't know if it was this exact one last year in AP Prep. There was lots of moaning and groaning and gnashing of teeth, as I recall, because you had to take 1 plus I squared to 3 times 1 plus I squared to 3, brute force that out, and then take that times another 1 plus I squared to 3. But now, you remember, yeah, you remember that. The trauma comes back. But now we have a better way. So we're going to convert it into polar form, and then it's going to be like a walk in the park using de Moivre's theorem. Okay? So I'm going to give you a head start on putting this in polar form. Don't wait for me. You can consult and collaborate. I'm going to give you a head start, and then I'll get going so you can check if you need to, and so people at home aren't sitting there twiddling their thumbs waiting for you to hurry up and get an answer. How are we doing? Are we in agreement? Yep. Okay, and so the angle that makes sine squared to 3 over 2 is the same angle that makes cosine of half. Is going to be the angle that makes tangent squared to 3, and that wasn't really an equality there, so I'm going to say tangent theta equals square root of 3. And that angle is how much? Okay? So our r cis theta, so this 1 plus I squared root of 3 is equal in polar form to 2 cis I over 3. Is that good to go? And then we're going to take that to the third power. So I'm going to say, just to make it easier notationally, I'm going to say that's x. And then we're going to take x to the third. And so x to the third is going to be 8 cis pi. And now let's go back to rectangulars because we know what the cosine and sine of pi are. It's going to be 8 cosine pi plus 8 pi sine pi And cosine pi we know is -1, and sine pi we know is 0. Isn't that crazy? Now there's something here. You remember back in your AP Prep, we talked about the fundamental theorem of algebra.
We did?
We did. I remember it like it was just yesterday. And we said that any polynomial equation of degree n, let me write this down, fundamental theorem of algebra. That sounds important. Polynomial of degree n has exactly n complex roots. So if you allow imaginary numbers, any polynomial of degree n has n zeros and roots. So, you with me there? So, if we look at, say, something like x cubed plus 1 equals 0, that is degree 3. It must have, according to the fundamental theorem of algebra, if we allow imaginaries, how many zeros? 3. Well, we can find 1 in our head, right? Subtract that 1 to the other side. Take the cube root of both sides. The cube root of -1 is, we used to do that and feel pretty good. But there's 2 more out there.
That's okay.
How do we find them? Aren't you curious?
Sure, it has something.
Of course you are. So let's think about this. Let me get this other clutter out of the way. Let's talk about the essentials. We have x to the third equals -1. We're trying to solve that. And we want to find all possible solutions. We're going to use De Moivre's theorem in a kind of crazy roundabout way. So here we have, I'm going to think of x as this x that we're looking for can be a complex number. Right, so it can look like a plus bi. Oh, we don't want to call it a plus bi. We're going to call it our cis theta in polar form. Okay, so there is our unknown x in polar form. That's the polar representation. Our challenge is, can we find the r and the theta? In fact, we're really trying to find 3 r and thetas to go together. Does that make sense, what we're trying to do? So when I plug this in here, and we take x cubed is going to look like, well, this is De Moivre's theorem. When we cube that, it's going to look like what? R cubed cis 3 theta, right? So now I've made the left side in polar form. I have the right side is stuck here in rectangular form. I don't want this equality, so I got to change -1 into its polar form. Well, I would say, the way I do it, you don't have to do it this way, but to me it just seems quicker and easier. If I plot this, let's see, -1 plus 0i. So it's going to be -1 on the real axis and 0 on the imaginary. You with me? So the r, the distance from the pole, and here we want to stay positive. So this distance is what? With me? And the theta is pi. So r is 1, theta is pi. R cis theta is going to be 1, right to 1 cis pi. Now we have equality. Okay?
Is this supposed to be the mind-bending part?
Yes. Can you feel it bending?
Yes.
Sometimes it hurts a little bit, but it'll go away in a bit. Okay? Now, for these to be equal to each other, the r's have to equal each other, and the thetas have to equal each other, sort of, right? Because when you go cosine, you get a weird kind of equality. We'll talk about that in a minute. R cubed must be 1. Well, we can do that. R must be Oh, we're almost there. Okay, you ready? Ooh. I was going to lose you there, Ken. So 3 theta must be pi. It doesn't really have to be pi, right? It could be pi plus some multiple of 2 pi, right? And that would still be equal to each other in terms of cosine. And you're right. If we had, cosine pi is the same thing as cosine of pi plus 2 pi, same thing as cosine of 3 pi, right? And that's also the same as cosine of 5 pi. I could do this all day. Well, I'm not going to do it all day. That's the good news. So I'm going to say 2k pi. Now, what's going to happen is, as we do this, as we start moving around the circle, pretty soon we're going to just start getting the same values back over and over again. So we're only going to get enough different ones as we have degree, because that's what's going to make these be different is their angle, theta. So we're going to say k is going to go from 0, 1, 2, 1, 2, 3. That's the 3, then I'm done.
But don't we already have a 0? Would there just be 2? I mean, like, we found a 0. Oh, I see, we're finding all the zeros with this one. Never mind.
Okay, you all right? Other questions? Okay, you all right to here? So 0, 1, 2. Now if I put 3 in there, it's just going to take me back to the same thing as you'll see in a moment when we get 0. So we're only going to get different ones, 3 distinct values here. So here's our values of x, I call this. We have r cis theta. So r we said was 1. Cis, I'm going to put 0 in for k. That's going to be pi. There's one answer. We'll call that the first cube root of -1. Second one, still the same r, cis. Now I'm going to go pi plus 2 pi. No, that's all I want. Oh, wait. Sorry, I goofed it up. Rewind the video. I didn't solve for theta yet. Oh, they're all going to be the same. I just said they weren't the same. Okay, do-over. Theta is going to be pi over 3 plus 2 thirds, or 2k, or however you want to write that, 2/3 pi times k, or whatever. Okay? Okay, now I'll see if I get it right. So the first one, and we're going to still say that k is 0, 1, 2. So k is 0, that's gone. We're going to get theta is pi over 3. The r is still 1, so we're going to get 1 cis pi over 3. Okay, come on, can't hang in there, buddy. Second one. Now I'm going to plug in 1 for the k. We're going to get pi over 3 plus 2 pi over 3, which is pi. That's the one that we guessed, right? We'll see that in a minute. Third one. Now we're going to plug in 2 for the k. And so we're going to get 1 cis pi over 3 plus 4 pi over 3 is 5 pi over 3. Now, why did I stop there? If I put in 3, then I would get pi over 3 plus 2 pi. Right, the 3's would cancel. That's right back to pi over 3 again. So you're not getting anything here. Let's write them in rectangular, because we know these. So we've got 1 times cosine of pi over 3 plus I sine of pi over 3. With me? He nods of heads yes. No. You have to move your head so I know you haven't nodded off. Okay, very good. So cosine of pi over 3 is 1/2. Plus sine of pi over 3 is, so I'm going to go square root of 3 over 2i. There's 1 of r cube root of -1. Oh, I bet you wouldn't have guessed that one, huh? Now we're going to do the next one. So we have 1 cosine of pi plus I sine of pi. This is the one that we could do in our head. Because cosine of pi is -1, but sine of pi is, so this is -1 times 1. There's that -1 we knew that one because that was a real number. We got that. Okay? And then we're going to get 1 times cosine of 5 pi over 3 plus I sine 5 pi over 3. I got to think about this a little bit. 5 pi over 3 is in quadrant 4, so it's going to be positive. And cosine of 5 pi over 3 is going to be the same as cosine of pi over 3. So that's going to be a half, still positive. Now in quadrant 4, though, sine is going to be negative. So whereas this one was a plus square root of 3 over 2, this is going to be a minus square root of 3 over 2i. Isn't that crazy? Now there's beauty to be seen here. Let's graph these a little bit, just so you can see it. So if you take the first one, and I'm going to think of it more in cis form. So all of these have a radius of 1. See that? 1, 1, 1. So I should have drawn my circle first. So there's a circle, use your imagination, of radius 1. The first cube root of -1 is an angle of pi over 3. There's that first one. The second one is an angle of pi. And the third one is an angle of 5 pi over 3. They're evenly spaced. Is that wild? All the same distance from the pole. I tell you what.
So if you know 2 of them, then you can just guess on all the others.
No, that wasn't the point at all. Never mind. All right. Come on. All right, see what you can do. Let's pick one out. What would be a crazy thing to find? Should we find the fourth roots of maybe -8, not 8, how about -16i? Oh, this is going to be fun. All right? Have at it. Consult, collaborate. I'll give you a head start and then I'll join in so that people on the video can watch it.
That would mean it's X.
Yes.
Yeah. Yes, that does sound right. Okay.
So, would be
So you give you a little nudge because getting started is the hard part.
So that there.
R to the 4 cis 4 theta is equal to.
Yeah, we can put that in.
Yeah, R to the 4.
So you just do R.
Put it in the wrong place.
So that means we're gonna have
What is that? 4. Yeah.
64. Isn't it? No,
Because we first have the 4.
256.
Oh, yeah.
How are you doing?
I am really.
It is confusing to start with. You want some help getting started?
Yeah.
So we're trying to find the, and if you know what you're doing, go on ahead. If you're getting stumped along the way, I'll try to give you a nudge. Because getting started is by far the hardest part. So we're looking for the fourth root of negative 16i.
Yes.
And we know there's going to be 4 of them. So I'm going to say, I'm going to introduce this variable x and say there's our fourth root of negative 69. I'm going to raise both sides to the 4th power. So I'm going to call x to the 4th equals negative 69. Now this x, I want to write in polar form. So I'm going to consider that to be r cis theta, where I don't know the r, I don't know the theta. That's our goal, is to find that r and theta. But when I take it to the 4th, that's going to be from r to the 4th cis 4 theta. The part that really stumps people most of the time is now this part is in polar form, but the negative 16i is still in rectangular form. So we have to write negative 16i in that cis form as r cis theta. So I like to draw an Argand diagram to do that. So again, here's real on the horizontal and imaginary on the vertical. So a negative 16i is going to be down here on that vertical axis down here. Now for that point, that pink dot right there, I want the r value, which is the distance from the pole. Well, that's just the 16. Okay?
Yeah.
And the angle, remember, goes from sweeping counterclockwise from the positive x-axis. That is going to be a 3 pi over 2.
Okay, that makes sense. Thank you.
Yeah, that's our. Now we have something we can work with. Okay, I'll let you give that a shot. I'm going to jump in a moment. I'll give you a little bit of a start. Macy, question?
I don't know if this is like, okay, so because it's an even root, do you have like 2 and -2 in your R?
Well, and see, there you go. We want the r to be positive.
Okay.
I mean, you can get to the right answer using an r of -2. You're going to get different thetas then. So I think it's going to be less confusing
So
to just always pick r to be positive.
So
R to go from there.
Yeah.
So then 4 theta equals 3 pi.
Okay, so now we divide by 4. I think we divided by 4. So now theta, because you
Four
divided
theta
by
is
4.
equal to 3 pi.
You divide by 4.
Yep.
Okay, you divide your 4
So now we have 6 pi. Plus, maybe k pi over, hold on 1 second, I'll show you the one there. Divided by k over 2. Because, so if we divide by,
0, 1,
because k, so we have 3 pi over 0, k to pi.
Oh, and 3, yep, you're right, you're right. And then,
Kat, how are we doing there?
I think I'm starting to get.
Oh, yeah.
Okay.
I did it.
Well, you have great resources around you there, so pull Aiden and Ted into the discussion if you need to.
Okay, so we need to test k, pi 0, 1,
pi
2,
of 2.
3.
That's great.
Yeah, sorry, I got it. So you're right, and then I 0. And then theta, yeah, 2 times pi over 8.
You got the part about.
Yeah, sorry, she's right.
Negative 69.
Okay, so
Yeah.
where was supposed to be that one of
So
the,
Article
so
is
will actually
pi over
have
16 says 3 pi over 8, right?
oh, right, so that's one
Article
zero. So 0, 1,
theta equals 3 pi over
0, okay, second one, yeah.
Yeah, so.
So
already put 3 over
So
8.
so plus pi over 2, which is also.
So wait a minute, no, I
Five,
can.
7 pi over 8.
You figure it out.
Just 3 pi over 8.
I mean, these are not nice values, so we don't know them. So I mean, you can still put them in rectangular, but then you're going to have to use your calculator. It becomes really time consuming and I think kind of annoying. So I would say, let's just, in this case, let's just leave our answers in polar form. And I'm going to draw the graph. You don't have to, but I think it's kind of cool to see that that beauty, or as Katya would say, you could just guess the last one.
I could just guess the last four.
Yeah, you find the first one, you find the one in the middle, and then you go from there.
Or you do it just like we did, like rose petals.
Yeah, you could do that too.
Where you get the first one.
I did, okay. That's
Oh, that's
nice.
so
Four
good.
goes straight across.
No, find me like, they're all like evenly spaced, remember? Yeah. So are these ones.
Alright, so you say, 4 theta equals 3 pi over 2 plus 2 pi n.
Okay, so what did you do?
Angle.
You set aside
So n is in the integer, and 3 pi over 2 plus 2 pi is just going all the way around. So that when you put in the plus 2 pi n, then you're including all the angles that are equivalent.
Divide by the one. Sorry.
Oh, you
So
can
we
find
have
like 8.
that.
Yeah, so what, okay.
Why did we divide?
So then
I don't know.
Two pi.
We all-
No, I
yeah,
know,
that's
it's
fine.
like, and I was thinking that, but then I don't know.
We're all like, yeah, okay.
I don't know how I.
Are you right?
I don't know either. It's okay.
Now we
Okay,
do it.
okay.
I really didn't understand anyway, so.
Over 4, okay.
I was
Okay,
Well, so
over
the pi over 2,
8. Okay, I got it.
the pi over, so you have pi over 2. You have 3 pi over 2 divided by 4. That gives you 3
Why
pi
does
over
it go
8.
out 4?
Why does it go like that?
Like you
Circle,
flip
why
it
does
in
it go out
5, that way it's 2 on top, I thought.
Like as opposed to 2?
3
Why does it go
pi 2
4?
divided by
Oh, it should be 2. You're right.
Okay.
Thanks.
I was confused that I was doing.
Yeah, no, you were right. Because our R is 2, so that should match that. So they're all a distance of 2 from the origin. And even though they start in kind of a funky place, the 3 pi over 8, because there's 4 of them, they're all 90 degrees
Yeah, that's what you
apart. So you just rotate over 90 degrees each time. Just think that is so cool. Yeah, I never learned that until I taught this. And I thought, I had heard of the Moiv's theorem, and I'd heard of finding roots like this, but I'd never seen it done. And I was like, oh, that is so cool.
You end up with theta equals 3 pi over 8 plus pi over 2.
Do you still need a minute, or are we? So we got done what I want. We got about 5 minutes. Do you want to practice doing a graphing, like a rose curve or a Lena song, or you want to do another find the roots of a complex number?
Did you practice a rose curve?
Should we do a rose curve?
Yeah.
Okay.
That's fun.
So I'm going to cut the video. Now,